This lesson will show how to compare two sets of data using center and variability. For skewed data, meaning data with outliers, we use the median for the center and the interquartile range for the variability. For symmetric data, we use the mean for the center and the mean absolute deviation for variability. Having a center difference less than the spread or variability implies significant overlap in the data values, meaning the data values are similar. Having a center difference approximately equal to the spread or variability implies some overlap in the data values. However, the data values are also somewhat different. Having the center difference greater than the spread or variability implies little overlap, any meaningful difference in the data values. Let's take a look at two examples. For the first example, we are comparing boys and girls' height, and the data values are skewed, which is why they're giving us the medians and the interquartile ranges. From the boy sample, the median is 61 inches, interquartile range is 3 inches. From the girl sample, the median is 63 inches, interquartile range is 2 inches. To compare the centers, we find the difference in the medians. 63 minus 61 is 2, and for the variability, the interquartile ranges are from 2 to 3. Notice the center difference and the spread or variability are somewhat close to each other, which implies some overlap in the data values. For the inference, we will state the difference in centers of 2 is close to the variability of 2 to 3. Boys and girls have similar height distributions, but girls tend to be slightly taller on average because the median height for girls is larger than the median height for boys. Let's look at a second example. Here we're comparing test values, and because the data values are symmetric, they're giving us the mean and the mean absolute deviation. For class A, the mean is 78, the mean absolute deviation is 3. For class B, the mean is 85, and the mean absolute deviation is 4. Comparing the centers, we find the difference in the means, which is 7, and for the variability, the mean absolute deviations are from 3 to 4. Notice in this case, the center difference is greater than spread or variability, which does imply little overlap, any meaningful difference in data values. Let's state the inference as the difference in centers of 7 is much larger than the variability of 3 to 4. Class B, which has the larger mean, has higher scores with relative little overlap in test scores with Class A. I hope you found this helpful.